So the important thing is now that you've got this chain reaction set up of going from force to acceleration, acceleration to change in velocity to new velocity, velocity to the distance moved to the new position. Now that you've got that little chain reaction set up, you can really study any force you want. Let's replace this constant force with a spring force. Because constant force is interesting. It gives you a parabola. It always gives you a parabola. It gives you nothing but a parabola. Spring force is a little bit more interesting. With the spring force, what we do, let's clear this part out. We're going to set this equal to a negative number. Let's call it -1 for right now, times the previous position. The way this works is however far the spring is stretched, the greater a force it exerts. But it always pulls it back toward equilibrium. That's what this negative sign means here. So we're going to hit enter here. And now we're going to click and drag with a fill handle here. And what you notice is, oh goodness, this got messy really quickly. What you notice is for each force, it's equal to -1 times the previous position. So we're going to use the fill handle to get that all the way down to 209 down here. What I want you to notice here is that the force is now changing, right? Because the force changes depending on the position. Let's take a look at what happens with our graph now. You notice that our graph here, it's going up at first, then it comes down, kind of like what we had before, but you notice there's an interesting little tail effect happening here. Let's see what we can change about this thing. Let's change the mass to just 1/10 of a kilogram. All right, let's come over to our graph here now. So again, we have kind of the same behavior we had before, right? Because we had a force pointing the opposite direction that we were moving in. So it's going to try to turn us around. But then what do you notice happens? It gets turned around again down here, and then it starts to turn around again up here. Let's do this. Let's make this go out a little bit farther in time. So we're going to grab this. Let's do another couple of seconds. Let's get this all the way down to 400. Because again, you've already set up the work. You might as well copy it down to explore what you can. All right, that goes down to 416. All right, so we're going to come to our graph here. We're going to go to data range. That's an important thing to learn how to do. Let's see, so this was what, 416? So we'll change that to 416. We'll change this one here to 416. There we go. What you notice is you get a cosine graph. Isn't that how a spring behaves? It goes up and down and up and down and up. Yeah, you end up with the exact type of behavior that you expect. Here's the reason this goes up and down and up and down. Right? Because when your position is really far out, right? So here it's at a maximum of about 3.3. So when your position is really far out, you've got a very strong force pulling in the negative direction, right? A strong force. Let's decrease these decimal places to make them easier to read. There we go. 2 decimal places ought to be fine. There we go. All right. So, like I said, when you've got a really strong force pulling in the negative direction, what does that mean? It means you're going to have a very strong acceleration. A strong acceleration means there's going to be a powerful change in the velocity, a significant change in the velocity. So your velocity, for example, here goes from about 0.5 meters per second to 0.15 meters per second in only 1/100th of a second. That's an enormous change in velocity. That also means your distance moved is going to be really, really small because you don't have that much velocity anymore. So your position is going to stall out. So you're going from 3.34 up to 3.37. Then you have to start turning back around because you still have this strong force pulling you backwards. You have a negative acceleration. You have a negative change in velocity. Your velocity ends up being negative, which means your position has to start to decrease. But then when your position decreases, eventually you get down to a large negative. Down here, this negative 3.37. That means you've got a large positive force, which means you're going to have a strong positive change in velocity. So your velocity is not going to be going in the negative direction very long. Eventually your velocity turns back around. And this cycle just keeps repeating itself over and over again with the data thanks to that negative in the force. That negative number in the force times the position means this thing is going to keep oscillating back and forth. So now that you have this spreadsheet set up where you can have a variable force, let's change this name to variable, you can really study anything in physics. And I'm not exaggerating there. As long as you know what the force is, you can study anything there is in physics. Let's suppose, for example, you take the spring, right? So you have this spring force here. And let's suppose you add in a little bit of air resistance. The way air resistance works, you take a negative times a number. Let's make it a small number, like a 0.1. And multiply that by the velocity. So we'll take the velocity over here, and we'll hit enter. That's going to serve to decrease your force a little bit. That's going to make it slow down. Let's make the whole thing slow down a little bit. So let's click and drag this down to copy that cell change forward. Notice I'm only having to change the force column. I don't have to change them to the others because the others are exactly the same every time. The only thing you change from going from one problem to another in physics is the force calculation. All right, there we go. We've got our force now. So now every single one of these cells is calculating the spring force and the air resistance force. So the spring force looks at the position, the air resistance looks at the velocity. Notice what happens to our oscillation here. Last time our oscillation was nice and steady, up and down and up and down and up and down. This one's still going up and down, right? It's still a spring, but it's losing some energy with each pass of the cycle, right? Because here I have a pretty high amplitude. Here it's been cut almost in half. Here it's been cut almost in half again, almost in half again, almost in half again. We're losing amplitude each time. Why is that? Because of this drag force, right? Drag force, air resistance, tends to rob things of their speed until eventually they level out. And you can see this happen if, for example, you make the drag force even stronger. Let's go from a 0.1 to a 0.5 all the way down. If I increase the strength of the air resistance, you notice I don't even hardly get any oscillations anymore. The thing goes up, comes down, it wiggles maybe a little bit right there, but then it basically comes to a stop. There's a whole lot of air resistance there. You can change this force to any formula that you want. You don't have to just build on the spring force. Let's suppose you have this thing as -1 times the position cubed instead of the position to the first power, right? This is like a super spring, right? It's a super strong spring. So let's fill this all the way down to 416, I think it was. And you notice here, we go back and forth. We lost that damping force, but I hope you notice this is not a cosine curve, right? Cosine does not get that straight. So it's like a super cosine or something, right? Where it's making this V that's almost sawtooth function. So it's rather different than a cosine. Even though it's still periodic, it's still repeating, it's rather different in terms of the curvature. All right, let's try one more modification to our spring here. So we've got our spring set up, the negative H2 up there, and then we're multiplying it by this exponential part, this Gaussian function, so that it kind of dies off a little bit as you get farther away. And we get kind of close back to a spring. It might be fun to play around with the numbers inside this one, like maybe you make this exponential part a little bit stronger. But anyway, like I said, now that you have this machinery, you can literally study any force that you want in physics. You can replace this formula with anything that interests you, any problem that you have in your textbook, and you can get an idea of how the thing moves with respect to time. So anyway, I hope that's been helpful to you. I hope you have fun with that. We'll take one more look at another thing we can do, which is moving in 2 dimensions, and I will see you for that next time. Bye-bye.